So B1n is the bandwidth of n stage of cascade amplifier, and B1 is the bandwidth of single stage of cascade amplifier, and it is multiplied by this scaling factor root of 2 power 1 by n minus 1. When you put n is equal to 1 here, you will get 2 1 by 1 minus 1, or root of 2 minus 1, you get equal to 1. So when you put 1, it becomes equal to the bandwidth of single stage. When you put equal to 2, it is root of 2 power 1 by 2 minus 1. You simplify, you get 0.643. If you put n is equal to 3, it is root of 2 power 1 by 3 minus 1. It is 0.510. What does this number 0.643 and 0.510 signify? So when I am cascading two single tuned amplifier, my bandwidth is reduced by 64.3 percentage. So what is the bandwidth of single stage? You have to multiply that by 64.3. So it is reduced to 64.3. It is reduced from 100%. So for single stage, the bandwidth is 100 percentage. So when I cascade one more stage from 100, it 64.3. If I cascade three stages from 100, it becomes 51. It is this bandwidth is becoming half. It is becoming 51 percentage. So as you can see, as we increase the n value, the bandwidth keeps on decreasing. Okay, so you cannot have compromising values for both bandwidth and gain. So when you cascade number of stages, you definitely have to compromise on the bandwidth. But what is increasing for you? Your Q factor will be increasing enormously, which will make your circuit tunable. So it will be, your circuit will be highly selective if the Q factor is going to be very, very large for a particular application. So if you want to have a minimal bandwidth constraint for an application, only option what you have is you have to reduce your Q factor. See, even after increasing the number of stages, I am certainly requiring the bandwidth to be considerably larger. I cannot compromise on bandwidth. In such case, you have an option to reduce the Q factor. Only then your bandwidth will become larger. Otherwise, if you cascade number of stages, the bandwidth will naturally reduce as per the logic. Gain into bandwidth equal to constant. Any doubt in this small topic? So this is a very small topic which will highlight the significance of, in mathematically, how much your bandwidth will reduce if you're cascading more number of single tuned amplifiers for applications. So any doubt or any query you have, you can ask. Okay, so now since the we have completed single tune amplifiers fully. So yesterday we have seen the derivation. Today we have cascading single tuned amplifiers on bandwidth. So now we'll slowly move into double tuned amplifiers. So I have told you how important is single tuned amplifiers with the exam point of view. So study it carefully. And this question, effect of cascading, is not required for the single tuned amplifier question. That question is asked, you have to stop with the bandwidth expression. That's all. And draw this graph. This is a separate question which might be asked for 6 marks or 8 marks. What is the effect of cascading? Or in 2 marks, they may ask problem. They will give the bandwidth of one stage and they will give number of stages. They will ask you to find what is the overall bandwidth of the circuit. So the effect of cascading can come either in 6 mark or it can come in 8 mark, or problem can be asked for 2 marks using this logic. Okay, I hope